this video, we'll be going over an A-level question that involves binomial expansion. Now let's look at our question. In the binomial expansion of 2k plus x all to the power of n, where k is a constant and n is a positive integer greater than 2, the coefficient of x squared is equal to the coefficient of x cubed. Prove that n equals 6k plus 2. So what we're going to do is we're going to write out the expansion of 2k plus x all to the power of n. So we'll write this in our normal binomial expansion. So we'll start off with 2k, so that's 2k plus x to the n, which is equal to n0 multiplied by 2k to the power of n times x to the power of 0. Now, the next term would be n choose 1 multiplied by 2k to the power of n minus 1 times x to the power of 1. Now, the next term would be n choose 2 multiplied by 2k to the power of n minus 2 multiplied by x squared. And the next term would be n choose 3 multiplied by 2k to the power of n minus 3 multiplied by x cubed. So the only two terms we need here is the x squared and the x cubed term. So let's isolate those two. So we know that the coefficient of x cubed is equal to the coefficient of x squared. So that's everything excluding the x squared and the x cubed. So we know that the coefficient of x cubed is n choose 3 multiplied by 2k to the power of n minus 3, and this is equal to n choose 2 multiplied by 2k to the power of n minus 2. So in this position, we can now use the equation that we are given with the binomial expansion. So this is n factorial over r factorial times n minus r whole factorial. And so this gives us the values of things like n choose 0, n choose 1, n choose 2. And so we just substitute those values in. So we can write this out, each of the coefficients out as n factorial over, so this is for the x cubed one, 3 factorial multiplied by n minus 3 factorial. And this times by 2k n to the minus 3. Oh, sorry, 2k to the power of n minus 3. And then the n choose 2 can now be written as n factorial over 2 factorial multiplied by n minus 2 factorial multiplied by 2k to the power of n minus 2. Now what we're going to do is we're going to cancel out our n factorials that we have, and then we're going to cross multiply. So what we can do here is we can move the 2k and n to the power of n minus 3 and 2k to the power of n minus 2 into the numerators of both these fractions, and when we cross multiply, we can swap them over. So we have 2 factorial times n minus 2 factorial over 3 factorial times n minus 3 factorial, which is equal to 2k to the power of n minus 2 over 2k to the power of n minus 3. So we're going to simplify the fraction on the right hand side. So we know that when we have powers and they're of the same number, so a to the power of b over a to the power of c, we can have a to the power of b minus c. So we can use this to get 2k to the power of, so our b value here would be n minus 2, and our c value here would be minus n plus 3, because we've multiplied the minus 1 into our n minus 3. So when we simplify this, we get 2k to the power of, so we cancel out our n's, and we get 2k to the power of 1, and this is equal to what we have on the left hand side. Now, with our left hand side, we can start to simplify things. And so we can expand out our n minus 2 factorial and our n minus 3 factorial. So n minus 2 factorial, just as the first few terms, we'll have n minus 2 times n minus 3 times n minus 4 times n minus 5, and so on and so on. And so on the denominator, we'll have 3 factorial times n minus 3, n minus 4 times n minus 5, and so on until it reaches 1. So what we can see here is everything beyond n minus 3 can be cancelled out on both the numerator and our denominator. And so what we're left with is 2 factorial times by n minus 2 over 3 factorial is equal to 2k. Now we can start to rearrange to get n. So 3 factorial, that's 3 times 2 times 1, which is 6. So we have 2 times 1, 2 times 1 times n minus 2, and now we can rearrange. So we have the 2 times 1 can be cancelled out, so we get n minus 2 over 3. And this is equal to 2k. Now you can move our 3 to the other side, so we get n minus 2 is equal to 6k, and n is equal to 6k plus 2. Now, if we go up, we can see that it falls into that same parameter. Now we have the second part of the question, part B. Given also that k is equal to 2 over 3, expand 2k plus x to the power of n in ascending powers of x up to and including the term in x cubed, giving each coefficient as an exact fraction in its simplest form. So let's see what equation that we're going to get. So we're going to substitute our value of k as 2 over 3 into our expansion here. And we're also going to use k in n equals 6k plus 2 to get our value of n. So we have n is equal to 6 times k plus 2. So that's 6 times 2 over 3 plus 2. And so if we multiply 6 in, we get 12 over 3, which is equal to 4. And so 4 plus 2 is equal to 6. So n is equal to 6. And our expansion, so we have 2k plus x to the power of n. We can substitute our values in, so we get 2 times 2 over 3 plus x to the power of 6. So this is equal to 4 over 3 plus x all to the power of 6. So we're going to keep 4 over 3 as that's easier to manipulate with the question asking us to give it in exact fractions. So if we scroll up above, we can see that we have expanded our equation here. So all we have to do is write this out again, but with all the values substituted. So we've brought down our equation here, and so we're going to substitute our values. So we have 4 over 3 plus x all to the power of 6 is equal to, so that's now 6 choose 0 multiplied by 4 over 3 to the power of 6 multiplied by x to the power of 0 plus 6 choose 1 multiplied by 4 over 3 to the power of 5 multiplied by x to the power of 1 plus 6 choose 2 multiplied by 4 over 3 to the power of 4 multiplied by x squared plus 6 choose 3 multiplied by 4 over 3 cubed multiplied by x cubed. So we can see here that our values, our powers of x are increasing. This was asked by the question, and we have all our values as fractions. So with our calculator, for our values for 6 choose 0, 6 choose 1, 6 choose 2, there will be the letter C on there that you can use. If you just give it in that format, it will give you a value. So if we put these values into our calculator, we get, so for our first term, 4096 over 729 plus, and for our second term, we have 2048 over 81x. So here we have x of 1, and now we're going to keep going. So our third term plus 1280 over 27 times x squared plus 1280 over 27 times x cubed. So in the first part, we know that the coefficients of x squared and x cubed are the same. So seeing them being the same here shouldn't put you off from having that as the answer. As always, thank you for watching, and make sure you subscribe so you don't miss out on any new content.